Okay, sorry about that. Okay, so I'm going to walk you through this lesson 33 supplemental activity with sound this time. So this is just extra practice deriving the analytic equation of a parabola. So that's you're solving for y. So given a parabola with a focus at 0, 4 and a directrix of the x-axis, so I'm drawing my directrix, y equals 0, and there's my focus, 0, 4, okay? And remember my parabola is halfway in between those things because the distance to the focus is the distance to the directrix, okay? And I'm going to do a sketch, and it's not super good, but pretend those two lines are equal. So I'm just going to pick any point on that parabola, and I know it should be the same distance from the focus to the directrix. And then what I'm going to do is I'm going to set up the distance to the focus. So from any point xy, so x minus 0, y minus 4. So simplified is x squared plus y minus 4 squared. Okay, the distance to the directrix is it's going from 0 to the value of y, so it's just y. And then solve for y by setting up distance to focus equals distance to directrix. So I'm going to set up that square root sign. Okay, so there's my distance to my focus, there's my distance to my directrix. I'll solve for y. First I got to square root both sides, or square both sides, sorry, to get rid of the square root. Then I'm going to expand that y minus 4, and I'm just going to follow the pattern. You square the first term, you combine them, negative 4y, and double it, plus 16 equals y squared. Okay, and then remember we're just solving for regular old y, so I can get rid of those y squareds because there's one on each side. And I'm going to move everything over to the other side. And I'll get negative 8y equals negative x squared minus 16. Divide both sides by negative 8. And my final answer is y equals x squared over 8. Becomes positive because it's two negatives. Negative 16 divided by negative 8 is positive 2. And there's my formula. That equation will give you the parabola that's described up there. Okay, I'm going to get this one partially set up. So I have a focus at 3, 3. Oh, I should have moved my mouse when I was making this video. And I have a directrix of y equals 1, 2, 3, 2, 3 right there. There's my point. Okay. All right, so my focus is at 3, 3. My vertex would be halfway in between. Okay, so I have the distance to my focus. That's the square root one. So I just go x minus 3 squared plus y minus 3 squared. And I take the square root of all of it. Okay, and I can't simplify that anymore. The distance to the directrix, it went from 0 all the way up to y, except for that little gap between 0 and 1. So we don't count that, we subtract that 1, that space of 1 there. So we're going to call that distance y minus 1. And then we have to solve for y by setting up distance to focus equals distance to directrix. I'm just going to go ahead and get that all ready to square both sides. Okay, and then what I'm left with is just what's underneath the square root sign, okay, and then I would just keep going on. For this particular one, I have a directrix of y equals 2, so the distance to the directrix, I'm going to help you out, is y minus 2. And then for this one, the directrix is y equals negative 3. So if you think about, you do y minus negative 3, which is y plus 3. Okay, that's kind of all you need to know, is you just subtract whatever your directrix value is from y. And if it's negative, then you're subtracting a negative, which is adding. Okay, remember, you're solving for y.